Hello everyone, this is me Hack, and this is part 2 of our Kubernetes for Hackers video series. And in our previous video we covered basic Kubernetes topic. Now in this video we are going to do a hands-on CLI of Kubernetes. So let's get started, shall we? So first I need a cluster to work with, and I don't want to use a cloud cluster for this because I don't want to worry about the cost. By the way, like running Kubernetes on a cloud provider is very expensive and it can cost you like hundreds of dollars. So we are going to use a local solution called Kind, and Kind stands for Kubernetes in Docker. By the way, before we go any further, if you're using Mac, you can install Kind using brew install Kind, or if you're on Windows, you can do wingit install kubernetes.kind. I will also attach a link in the description on how to install Kind. Now let's go further now. So what Kind does, by the way, before we go any further, we need to know what Kind does. So Kind basically creates a real control plane, but the nodes here are the Docker containers on your laptop or your PC. And the reason that's useful is that Kubernetes does not care what nodes actually are, and the commands, the networking, the behavior remains same throughout. Does not matter whether you use something local like Kind or Minikube, or something from the cloud like EKS, AKS or GKE. In Kubernetes, like infrastructure can be different, but the top Kubernetes layer remains same throughout. So whatever you are going to learn here, you can apply in any of those Kubernetes environment, and the command like mostly remain the same. Like there could be few changes with permissions, or like how identities are treated in each of those instances, but the Kubernetes in general is mostly same. So the first thing which I want to understand is like what am I looking at physically. So I will run a command called kubectl get nodes -o white flag. This shows me the node, the actual machine doing the work, and the -o flag gives me the IP addresses of those machines. And why do I care about the IP addresses? Because like IP ranges can tell me how the network of this Kubernetes cluster is laid out, and if there's only one node, everything is running on a single machine, and if there are 10 nodes, then it means that workload is spread out. And now things like node to node communication and scheduling matters, and from a security point of view, a single node means that if that node is compromised, everything in that Kubernetes cluster is compromised. But if there are more than one node, then it also means that it has a larger attack surface, but it also means more isolation. So if we are able to pool one node out of those 10 nodes, it doesn't mean that we can pool the entire cluster. And it also like changes like how we think about risk in Kubernetes. Next we will see like what's actually running on those nodes. So we will run a command called kubectl get pods with a -a flag, and over here -a flag means to display things from the entire namespaces. And you will notice that there's a namespace called kube system, and this namespace is very important because it has all the critical paths which is needed to run a Kubernetes cluster inside it. So it will have something like code DNS, kube proxy, etc. So if you see like any of those pods like crashing or not running in that specific namespace, then it means that cluster is going to behave strangely, and pods might not work, or like apps might not be able to work, etc. Before I start deploying anything, I want to create a separate space to work in, and we can do that by using kubectl create ns demo. Let's create a namespace called demo. A namespace is basically a way to organize things inside the Kubernetes cluster. Think of it like a folder on your computer. Your apps goes into one folder and someone else's app goes into another one. Now one thing to be clear about is that namespaces are organizational boundary, not a security boundary. Just because something is in a different namespace, it doesn't mean that it's isolated at the network level. By default, pods in a different namespace can talk to each other, you need a network policy to actually restrict that. We are going to deploy a workload and understand like how pods work. So we will start by deploying an Nginx server inside our demo namespace. uh, but I want to like also like explain something that is an easy miss for a lot of newbies, is that they will confuse a pod to be a container, but like technically like the thing which we are running right now is not a container, it's a pod. And what's a pod? It's basically a wrapper in which you can run more than one container, and usually it's like one, but sometimes it can be two or three. And if there's a main app, it can have a second container called sidecar, and basically it will handle logging and proxying. The important thing to understand over here is that a pod shares the same environment with uh, the containers it's running, and it will share the same storage volume and same IP. Next, we will look at the IP address of the pod which we ran, and we can do that using kubectl. We can specify our namespace and do get pods -o white flag. And over here, what we are seeing is a real routable IP which we can access from the cluster. And if we run a different pod, it can, the other pod can talk to it. But here's the thing, like pods are designed to be temporary, and let's say like if the pod dies or like recycles, we will also lose our that IP address. Now let's suppose that we have to create of let's suppose that we have to like create a service or something, and like a hard coded file, and it has that specific IP. Now our app will be broken, so how we can like mitigate that? So this is where something called services in Kubernetes comes in. So a service basically sits in front of your pod and gives you a stable ways to reach them. It does three things. Like firstly, like it will give you a virtual IP called cluster IP that does not change even when the service behind it gets replaced. Secondly, like it will give you a DNS name, so other applications can reach the service just by using the name web instead of remembering an IP. And thirdly, like if there are multiple pods behind the service, it load balances traffic across them. So the service is really the stable front door to your application inside the cluster. So far we have been looking at everything from our terminal, but I want to see how it looks like from an inside the cluster, from inside a pod. So I'm going to spin up a temporary pod with a call installed in it. The RM flag means the pod gets deleted as soon as I exit. Now inside the pod we will make a call request to the web, a names web service, and look at that, like I just made an HTTP request to web, just the name, no IP address, no port. I just specified the service name, and the call was able to call the Nginx server. So how did that work? We can figure it out using ns lookup, and there's it. Like when I make a call request to web, what happens in the backend is that it will call the cluster's DNS system, which is core DNS, and that DNS system resolves our service name to a cluster IP. And this is how like application communicate inside a Kubernetes cluster. They don't use an IP address, they use name. Service A talks to service B just by calling its name, and DNS handles the translation behind the scene. And the routing is actually handled by something called kubeproxy. Now here is something which you should keep in mind, is like everything depends on every like internal communication depends on the DNS. So if core DNS goes down, applications won't be able to find each other on a higher level. It will look like the pods are working fine, the networkings are working fine, but internally like they won't be able to make calls and your application might not work. So this is the last part of the video, and in this part we are going to cover something which is very important for us security professionals or hackers, is the service account and the RBAC part of the Kubernetes. And I believe this is the heart of the security professionals for us. And so if you come from a traditional security, think service account as an identity you inherit after compromising a pod. In AD you care about the user context you got, in AWS we care about the role we get, and in Kubernetes we care about the service account which we get, because because that identity decides what you can do against that API server. So we will first start by listing the service account in our namespace. Then we will check what that specific service account can do in that specific namespace, and that is probably the first thing which I do when I land in a pod. Next we will create another service account and give it pod read access. I will compare like both of those like service accounts again and see like what these service accounts can do. So we have like we are going to run kubectl auth can I list pods again, and with this one let me just copy this again. First we will like run kubectl auth can I list pods as a default service account and see whether we can list pods or not, and over here we get a response no, and we will copy this command again and we will try to run the same command, but we will check whether this service account demo app reader can list pods or not, and we see yes. Now we will dig a little bit deeper and we will see what this specific service account can do and what's the difference in terms of privileges. List, and I will copy this thingy again, and over here we can see that we have a permission to list pods and get pods, but if we do the same but with for but if we go and check our default account, we can see like we don't have any specific permission. We can't really do with the default account, but with our custom service account we have permissions to list and get pods. So this is it for today's video. Thanks for tuning in. Hope you have a great day. Bye.